AWS already has a caching system. It is called Elasticache. In this session, we discuss, however, DAX. DAX is another caching system on top of DynamoDB. The use case is this. If you need to go from milliseconds to microseconds and to improve the read performance, not the write performance, then you would want to use some kind of cache, though DynamoDB already today has a milliseconds latency, which is quite good. So not necessarily we want this additional boost in performance, but if we are in a high intensity auction website, then maybe we want this microseconds latency. So there is already a cache system, as we said in AWS. It is called Elasticache. And Elasticache, the difference is that Elasticache is a separate service. It already supports more data stores, not necessarily only DynamoDB. It's more generic, and we need to modify our application code in order to support Elasticache. And with DAX for DynamoDB, this is not the case. DAX is just, we enable with one click DAX and we get the caching, not for free because we need to pay for it. And what do we pay for in DAX? We don't need to change any of the APIs. We don't need to change the way we access the database. We get the same exceptions. Everything is the same. But with Elasticache, which is a full-blown cache system, we would need to change the API and change the calls. So it's like a mini cache that we toggle on with a click on top of Dynamo, or of course with SDKs and CDK on top of DynamoDB, and we get increased performance. It's a mini cache for DynamoDB. With Elasticache, we would have additional overhead for managing it, and it would support also a lazy load cache. So Elasticache is more of a full-blown solution, where if we read something, then it would also be inserted into cache. But with DAX, it's called write-only cache, which means when we write an item to the database to DynamoDB, then it is being inserted into the cache. So if our use case is that we just dump tons of data inside DynamoDB and then we gradually read it over the next month, this is not a good use case, because it's going to be a good use case if we have session information which we write and then read, okay? Because it's a write-only cache. This is where the cache is getting populated. So DAX has its own backend with EC2, where it actually does the cache actions, and we are going to pay for these EC2 instances. So as we say, it's EC2 instances, so depending on the type of the instances and the number of the instances, this would change how much we are going to pay for it. If we get an item and it's not in DAX, we have a cache miss. In this case, DynamoDB would do the usual operation of an eventual consistent get item operation from the DynamoDB. So DAX, as we said, it's a cache. It's a mini cache, an in-memory cache which can increase the performance of read operations for DynamoDB up to 10x performance optimizations, basically from milliseconds to microseconds, as it's an in-memory acceleration cache, and it would improve only the read performance and not the write performance. It's good for heavy bursty workloads, and we won't need to change any of our application logic because DAX API is compatible with DynamoDB API calls. The pricing, as we said, is going to be per node hour, because it's going to launch instances on EC2, and depending on the instance type, and how many hours they are actually working, then this would be our pricing for DAX.